All right, this is 6.3, and this is about graphing exponential functions. We're going to be flipping back and forth here, but should be able to keep up, I'm assuming. So, first thing is some definitions here. One is, what is the x-axis? Well, you know what the coordinate plane is, and there's two axes, right? The x-axis and the y-axis. So, when we talk about the horizontal axis, right, that's your x-axis, and the vertical axis is your y-axis. Now what happens is with these exponential functions, they have what they call horizontal asymptotes, meaning these are horizontal lines that the curves approach very closely, but never touch. So like if I had a graph here of an exponential function, right, this function is going to come very close and get close, 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 but it would never touch the x-axis. So in this case, the x-axis could be the horizontal asymptote. So that red graph would never cross it. Okay, next. All right, we're actually going to go back to the lesson. All right. So yesterday in an exponential function, we talked about what these functions have. All right. And we said an exponential function is f of x equals a times b to the x power, right? Now b gave us two things. If b was greater than 1, we're going to say this graph increases, meaning it's going to start low, and from left to right, you'll see the graph increasing. If b, the base, is between 0 and 1, it will decrease, meaning it'll start high on the left and decrease to the right. Okay, so with that, right, we have 3 or 4 exponential functions down here. The one thing you have to note is the base of an exponential function can never be a negative number, okay? The a value can be negative, but not the b. So if we look at these, if you had to guess right now, right? If I look at f of x equals 2 to the x, I want you to determine if these functions will be increasing from left to right or decreasing from left to right, okay? I don't know what just happened there. So we want to determine again if the graph is going to be increasing from left to right or decreasing from left to right, okay? I don't know why this keeps doing this. So real quick, what do we look at, right, to determine that, all right? I can get this back. Sorry. So when we look at this, if my base is bigger than 1, right, we know it's going to increase from left to right. So this is the graph of y equals 2 to the x power. If you notice, the x-axis acts as a horizontal asymptote, right? So as from left to right, it increases. If I look at 3 to the x, is that going to be increasing or decreasing from left to right? That would be increasing. Again, this one's going to be a little steeper because the base is a little bit bigger. When you look at the next one, 0.5 to the x, since that's between 0 and 1, you know right away that that's going to be decreasing, all right, from left to right. And if the base is 0.2, again, that will be decreasing from left to right, okay? So now it says here for both increasing and decreasing functions in a form f of x equals b to the x, the x-axis is a horizontal asymptote. And if you look here, right, this graph will get very close to that green line, but it will never ever cross it, all right, because the x-axis acts as a horizontal asymptote, right? So this one here, y equals 0.5 to the x, same thing, right? Now, one thing I want you to notice here is when we talk about a horizontal asymptote, right, it's always the equation of a line, and since the line is horizontal, it's always y equals a number, and the number is going to be the y value that the graph is approaching, all right? So in this case, the y value of the x-axis is 0, so y equals 0 would be the horizontal asymptote here. Okay. So real quick, if we look here, which of the functions are increasing, right? If I look, that's less than 1, so it's decreasing. That's greater than 1, so it's increasing. That's less than 1, so it's decreasing. It's greater than 1, so we would say for this one, letter B and D. Okay. What is the asymptote for f of x equals 0.2 to the x, right? When I look, it would be the line, the x-axis, or the line y equals 0. And we'll talk about that a little more. Okay, so real quick here, back to the study guide you printed out. All right, the main idea, the base of an exponential function determines if the graph increases or decreases, right? So in an exponential function, the values of the base can be what type of numbers? They always have to be positive numbers, right? Or numbers greater than 0, right? What values can be not be, all right? 1, they can't be negative. But if you think about it, if I raise 0 to any power, what's it always going to be? 0. So we're going to say the values of the base cannot be 0. And if I look, if the base is 1, 1 to the first power, 1 to the second power, 1 to the third power, right, will always be the same. Therefore, the base cannot be 1. So it basically has to be a positive number between 0 and 1 or greater than 1. Okay. So right now, in these examples, when you look at the first graph, all right, from left to right, what are we doing? Are we increasing or decreasing here? Here we are decreasing. So this graph is decreasing. So if you had to take a value of b, that would be a value between 0 and 1. When I look at the next one, right, here, from left to right, what are we doing? The graph is increasing, which means our base would be greater than 1. Okay? So some important things here, right? Anytime we find the y-intercept, okay? Anytime we find the y-intercept of an exponential function, we can always plug the values in. The y-intercept, any graph that crosses the y-axis, right, will always have an x value of 0, all right? So for the y-intercept here, if I plug 0 in for x, right, any number, right, if I go to my calculator, any number to the 0 power is going to be 1, okay? So the y-intercept for the function f of x equals b to dx will be 0, 1. Now, if we put a value of a in here, right, if we take any number and raise it to the 0 power, we get 1. But what is a times 1 always going to be? A. Therefore, we say the y-intercept, if there's an initial value other than 1, the y-intercept will be 0a. Okay. Another point that's on here is if I plug 1 in for x, you'll always get b as your output. Now, if I go over here and there's an a value here, when I plug 1 in, the value I would get here is a times b, and that would give me another ordered pair. All right. So next, in the horizontal asymptote, if I were to graph this, would be the x-axis or the equation y equals 0. Over here, if I have a times b to the x, right, this would also have an horizontal asymptote as the x-axis or y equals 0. Okay, the domain of these, since remember, domain is all your x values, right? So if I graph this, every x value would be covered. So we would say all real numbers. And same thing here. So for the domain of all of these, they will always exist at every x value. So it would always be all real numbers. So the range here, if my horizontal asymptote is at 0, right, we're going to say all positive numbers, right, or y is greater than 0. And very similar to here, either y is greater than 0, right, or y is less than 0. So right now it's so right away here, if we're trying to write the equations of these functions, we look at two things: the y-intercept and the value of the ordered pair 1 comma whatever b is. So when I look at this equation here, notice how the y-intercept's at 0, 1, and I have a point at 1, 4. Okay. Notice when I have the ordered pair 1, 4, right? And my horizontal asymptotes here, that tells me b to the first power is 4, and that tells me my base is 4, which is why you get this function 4 to the x, right? So the ordered pair, like the value of y when x is 1, will always give you the b value. So my next one, if I look here, right, if x is 1, b was 9. If you look, my equation is 9 to the x power. Over here, when x is 1, y is 1/2, right? Because that's 0, half, 1. If you look, your b is 1/2. Okay, and same here, 0.25 to the x. Now when we go to write the next one, it's a little different and they kind of guide you through it. It says write the equation in this form. So the first thing we're going to do is find the y-intercept. If I look at the y-intercept, that's right here, and that's at 0, 3. So the y-intercept is 0, 3, and the a value of the function then has to be 3. So remember, when I look at this, why do I know it's 3? Because even if I don't know the base, if the x value is 0, 3 times b to the 0, this will always be 1, which tells me that is 3. Now, the point when x is 1, if I follow this up, if x is 1, y is 6. So, the point where x is 1 is 1, 6. So the b value of the function, right, is going to be 2. How do we get that, right? Well, if I do 3 times some number to the first power, right? Well, if I know the output of this is 6, I know b to the first is b, so 3 times b equals 6. So if I divide by 3, b is 2. Okay, so again, where do I get this? We know f of x equals 3 times b to the first power. But what is the y value here? The y value is 6, so I'm able to set up this equation to solve for b. So the equation of this function would be f of x equals, right, 3 times 2 to the x power. All right. The other thing you can do if you wanted to, right, if you know it's exponential, if you create your table 0, 3, and you have 1, 6, what did you multiply here, right, to get 6? You multiply by 2, so that's your b value. All right. So let's go take a look at some examples. All right. So if we look at these, right, what is the domain of this function, right? Well, we said the domain of an exponential function is just going to be all real numbers. So the next one is asking, what is the range of this, right? So if I look at it, if I go and graph it, now to graph it, I'm using a website called Desmos. So if you go to desmos.com, you can do this, right? So if I put that function in 3, and then I hit times, or just go parentheses, right? 2, I'm going to hit the little caret key, right? And raise that, excuse me. I'm going to close the parentheses and then go caret key x. And this is the function. Now if we look, even if I zoom in and out, right? When we talk about the range, we're talking about the y values. Does this line ever cross the x-axis? No. Therefore, we're going to say that the range is, it starts at 0 on the bottom. Remember, starts at 0 on the bottom, right? And it goes all the way up to infinity, right? So we're going to say it's all real numbers greater than 0, or they might say y is greater than 0. Okay. What is the y-intercept for f of x equals 1/3 to the x? Right away, if I just plug 0 in, what is f of 0? F of 0 is 1/3 to the 0 power. Well, anything to the 0 power is just 1. And if I wanted to look too, I could also graph it. So I'm going to just change this to open parentheses. Oh, let me delete this. Right, I'm going to go open parentheses 1 divided by 3. Oh, outside the parentheses, I'm going to go to the x power. And if I look, if I zoom in here, the ordered pair there, 0, 1. That is your y-intercept. Okay. So number 4, is this graph increasing or decreasing? If I look at B, is that greater than 1 or between 0 and 1? It's between 0 and 1, so this is decreasing. What is the y-intercept of this next one? Now, when I graph this again, the y-intercept, if this changes to 1/2 to the 0 power is 1, so f of 0 is -2 times 1, right? Because anything to the 0 power is 1. So f of 0 is -2. So my y-intercept here would be 0, -2. If I go ahead and use decimals to graph it, I go -2 times 1/2, arrow out, parentheses, to the x power. Notice that it crosses the y-axis at 0, -2. Okay, so what is the point on the graph, right, when x is equal to 1? Well, if I look here, if I plug 1 in, 2/3 to the first power is just going to be, so f of 1 is just 2/3. Okay, so the point would be 1, 2/3. Okay, now this is a graph of the function, right? When I look at this, right, what is the function? First thing I'm going to do is find the y-intercept, right? And the y-intercept is 0, 3. Then what is the value of y when x is 1? All right, so the ordered pair is 1, 5. So here's what I would do. I would create the table, and you have 0, 3, 1, 5. Actually, I don't like this graph, so I'm assuming let's look at this. I think what they're doing is making this 1, 6 instead. Sorry about that. So if I make my table here, remember, f of x equals, this is your a value. Your y-intercept is your a value, so that's 3 times. What did I multiply 3 by to get 6? 2. Therefore, that is my base, and raise it to the x power. So creating a table makes that easier. When I look at the next one, my y-intercept is 0, 2. So f of x equals 2 times. Now I have to find another value when x is 1. So when x is 1, right, this is kind of an interesting one, right? That's going to be like 1, and then let's just go 1.4. Okay, so if I make this table, I have 0, 2, I have 1, 1.4. Okay, what did I have to do to 2 to get 1.4? Right? If I do 1.4 divided by 2, it gives me 0.7. So my base is 0.7 to the x. Right? I don't like those problems because the ordered pairs do not come out very nicely. All right. So this one says, for what values of x is f of x equal to, sorry, they got cut off. Let me take a look at it. F of x equal to 1, right? So if I look for a y value of 1, right, I go down here and I scroll. If I'm not mistaken, it looks like it's towards about -5. So I would say when y is 1, so this is when y equals 1, if I draw a line over, what's the x value, right? I would say x is -5. Okay, and then this graph of the function form, a times b dx, what is the function, right? So right away, the first thing I do is find the y-intercept and my a value, which is 0, 3. So right away, you know it's f of x equals 3 times something. So right away, I can eliminate that answer and this answer. If I look at this, we are decreasing from left to right. Therefore, I know my b value has to be less than 1 or greater than 0. So it has to be letter C. All right. So do me a favor. Go ahead and try to do your best on this. And if you have any questions or you need more clarification, send me a text.